Forecasting is predicting the future. What we cover within the class, these videos are all techniques that teach you how to forecast. The techniques that are covered in the book are trend, moving average, exponential smoothing. There's also a way to evaluate if a forecast is good or not, a forecast accuracy. So the book also covers different statistical methods, different techniques to evaluate if a forecast is good or not. One of the techniques is called mean absolute percent error. And so this video covers this also. There are some techniques that you do not need for the homework, or they're not in the book, and that's this decomposition method, seasonality, trend adjusted exponential smoothing. Actually, I think maybe this one you probably need to use for the homework, but these you don't necessarily. But they're just techniques out there to show you that there are a lot of different ways to predict the future. And they're a combination of data-driven and based on expert opinion, gut feel, and all of these are legitimate. And this is just kind of the starting point for different forecasting methods. So certainly forecasting is used for planning. We'll talk about what goes into a forecast. We'll talk about these different techniques, the moving average and exponential smoothing, also regression and trend analysis. There is expert opinion that you can use, so judgment or qualitative forecasting, and you can combine these, and you should. So forecasting is predicting the future, and once you have a forecast, that's where you can use this to make decisions. The other real cool thing about regression-based forecasting models is you can actually move demand around based on policy. So rather than just saying demand is something that we can't control, we can actually control demand by looking at what are the drivers that impact demand and maybe control those. So we can move demand from a high volume time to a low volume time. So rather than add capacity, we move our demand around. So some terminology, the planning horizon is the time that you need to make a decision. There certainly are strategic plans where you're looking out a decade out. I know when I worked at the winery, we had to forecast far enough out to allow farmers to plant a new vine and let it mature before you can get a grape. So that's very strategic type decisions on what part of the California that you wanted vines and what type of vines, and negotiate that with farmers when they were growing these grapes for you. We also have plans where we've got to do staffing, adding equipment. Those are shorter time frames. And then you get to the point where you're actually doing daily, how many people or what are we going to work on today? The time bucket is for strategic decisions are probably annual buckets. As you get closer, they may turn into quarterly, monthly. Really, the time frame needs to be at a level that you can make a decision, and it's important, but not any more detailed than that. So if you've got a time frame that are in minutes and you don't physically have time to make decisions from minute to minute, there's no reason to forecast in minutes. So pick a time bucket that you can use it to actually make a decision to change the next time period. A time series is looking at historical data that is ordered by time. And when you look at historical or actual information, what you're looking for are patterns. And a trend is something that's clearly going up or down. Seasonal patterns are things that are derived around a calendar year or a month or even a day, but they're repeating patterns. Cyclical are things that are very long time periods, like the economy, the stock market life cycles. There's always variability in a forecast. It's hard to predict the future exactly. So we need to be careful and be able to understand the concept of noise or things that we don't want to overreact to. And the models that we use help us distinguish between patterns and noise. And then occasionally you got these things that happen that are one-time unique events, and should that be something that you plan against in the future? And these are just pictures of patterns that you've got from a time series. The things can be linear or nonlinear. This is when we're looking at seasonality, and you can see in this case energy consumption or natural gas consumption. It goes up when it's cold and drops when it's not. The technique that we'll use to measure forecast accuracy is always based on you have to have what really happened and you have to have a forecast. So if I was going to evaluate the accuracy of a meteorologist who predicted the high temperature on a daily basis, then I would need to go back and look at what did they say was going to be the high temperature, and then after that what really happened, and once I have that I can calculate an error. And then with that error we can do all kinds of things. There's one statistic called the mean squared error. There's another one called the mean absolute deviation error, or MAD. The one that we'll use in the class that I want you to it's a scalar. It doesn't have any units of measure. It's just a number. So it allows you to compare forecast from products that maybe are in the ones or twos to products where the volume might be in the millions or something, a large number, because it's just it's a percent error. And what you do is that for every time period we can calculate we'll know what really happened, which is the actual from the forecast, and then you divide by what really happened. So to get a percent error, you take the difference between what really happened in the forecast, and then you standardize it by dividing by what really happened. And you do this for all time periods. And then these lines on the outside tell you that you always just take the absolute value. So we're not looking for any bias. We're just looking for differences. And all of these just show as a percent. And then finally you divide by how many forecasts you have to give you a mean absolute percent error. And the videos will show you how to do that. So the techniques that we'll cover in class are time average, a moving average, and exponential smoothing, regression. So here's the moving average, and all the moving averages, there's a video on it, but what we do is that we take recent observations, you decide how many recent observations to take, and look at the difference, or add those up, divide by how many we got to get the average forecast. So in the stock market, one of the common metrics is a 50-day moving average. So they take the most recent 50 days, take the average of that, divide by 50. You control the lasso, or the number of, in this case they're using the terminology K, how many to include. Generally when you include a lot, you've got a forecast that is slow to change, and if you don't have very many, you got a very responsive forecast. Neither one is right all the time. Neither one is best all the time. You can use forecast accuracy methods to evaluate what K should be. Something very similar to a moving average, but it allows you to elegantly weigh old history differently than new history, is the exponential smoothing. And again, we always, what we need is that we always need, if we're forecasting the future, we need to know what happened previously and the previous forecast. And then we define something, or we just choose the value of something called a smoothing constant, which is alpha. Alpha is a number between 0 and 1. We decide what that is. And you can see that when alpha is really small, we don't give a lot of weight to just what happened. So if alpha is 0.1 or 0.2, we don't give a lot of weight to this. We'll wind up giving weight to our older forecast. The reason it's called exponential smoothing is that as you can algebraically show that alpha winds up getting multiplied by itself, and you'll get alpha squared, alpha cubed, and alpha is always a number less than 1. So all it does is it gradually lets older history fall away and newer history more important. You decide the severity or how quickly old history falls away by choosing alpha. And again, there's a video that shows you how to do that. Regression is based on, or trend analysis is based on regression. You can look at one independent variable, just like time, and that's simple in a regression. but you can what the videos will cover is using the add-in the linear trend. This is just a trend line, but you can also use data analysis regression techniques, and that's what you're going to need for multiple regression. And then you can include things that aren't necessarily time periods. You could look at other things and do a multiple regression. You don't ever want to throw out expert opinion. Expert opinion is important. Even if you have data or you don't have data, there's probably going to be something out there that's qualitative in nature, people's just thoughts. And you can certainly use customer surveys. You can use inputs from salespeople that are close to the actual demand. I think that's important to modify any time series or math model. The Delphi method is an iterative approach. What you do is that you're really predicting something that's very strategic, something that maybe there's no math or data to predict, and you work with a group of experts. So you select experts and you survey them. They generally don't get in a room and fight it out. It's more as that you survey them, and you probably start out with fairly open-ended questions, and you throw out kind of the extreme, the outliers, and repackages it as another survey and give it to the same experts. And you do this several times, and generally there's a consensus that will happen, and that's when you don't have any data at all, or it's very strategic and just trying to project the future or the history into the future is not as important as using experts, and that's what this Delphi method is. And keep in mind, there's tons of different techniques, and you probably ought to use more than one. There's more sophisticated techniques that integrate a series of things, and you should use more than one. We're not going to cover in class, but you can certainly put a control chart, put a tracking signal, and track your forecast over time to see how good it is, and if as the forecast, if it moves away or it's always underperforming, it might be an indicator that you ought to change forecasting methods. And that's what these tracking signals of forecast do. Okay, that's enough of an overview, and then the other videos move into Excel and actually some techniques on how to forecast. Thanks.